Now, another type of question that involves discriminant and nature of roots could be that you are supposed to show that the roots of a certain nature, alright? So we have an example here. Show that the solutions of the equation x squared plus kx equals to 3 minus k are real for all real values of k. So in this case here, you're supposed to show that the roots are real roots, which means that eventually you have to show that d is greater than 0. Alright, at this point here, you can't start with that. You have to start with the general form. So what we need to do first is let's write out the equation. And we are going to use the discriminant, but the general form. So before we can do that, let's bring everything to the left to make this an equation with equals to 0 on the right. So we have kx plus k minus 3 equals to 0. And we're going to identify a, b, and c. Alright, so a equals to 1, b equals to k, and c equals to k minus 3. Now, once you have that, you are going to use, as I mentioned, the general form. So discriminant is the same as b squared minus 4ac. You can't say whether it's greater than or less than or equals to 0 at this point because you're supposed to show. Alright, so using your b as k, your a as 1 and your c as k minus 3, we have k squared minus 4 plus 12. Sorry, this is negative 4k. And somehow we need to show that this is going to be positive, alright? And the best way to do this is by using completing the square method. So what I'm going to do now is that I'm going to split this into two parts. I'm going to use completing the square on this part here, alright? So when I want to do a completing the square, when I have k squared minus 4k, so I'll have k, and I halve this. Remember, minus 4k means you have minus 2k and minus 2k, alright? So if you need a review, please go and look at the previous video, alright? So we have minus 2 here. And basically, right, so minus 4, we split into 2, so we get minus 2. And there was a gap that we had to plug, so this was actually negative 2 squared. And the plus 12 was from the earlier part. Alright, so we have it as k minus 2 squared minus 4. And we'll have k minus 2 squared minus 4 plus 12. And we'll be able to have k minus 2 squared plus 8. Alright, so this is in the completed square form. Alright, so in other words, this is my discriminant. So since they say that they want to show that the solutions are real, alright, so real solutions would be positive or equals to 0, because you can have real and distinct, or you can have real and equal. Alright, so these are two cases subsumed into this one here. Okay, so from here, can we really show that this is positive? Okay, so let's have a look here. K minus 2 squared. Anything, whatever number that you have down here, when you square it up, right, it will definitely become positive, isn't it? So we can have k minus 2 squared is definitely positive. Alright, and plus 8, isn't that positive as well? So I can also say that k minus 2 squared plus 8 is positive. So since this is actually your discriminant, I can say that my discriminant is positive. Okay, now for this case here, right, it could be also like, for instance, this one it's positive, right? So this is your discriminant, you put it as d, and so in this case here, we can say that therefore they are real roots. So you prove that this whole thing is positive. So you don't start with the fact that you have d greater than positive at the beginning. You try to use the completing the square method. Now this is the most powerful way to always show anything that is positive or anything that is negative. And why this is the case is because when you have the completed square form, you have a square form, and this square form will always tell you that this part here is positive. Alright, so this is a powerful method to use when you need to show that anything is positive or anything is negative.